No dobra. I think I will start anyway. We have not too much time. I have to explain why ecohydrology becoming more and more important. Recently, Stefan proposed two scenarios in Anthropocene. One, red scenario, which means that we are still emitting lots of the greenhouse gases and Earth become hot and hot. And people are focusing now on this element, how to reduce emission of pollutants and how to reduce ecological footprints. But second side of the coin is the necessity to enhance ecosystem structure. Because without ecosystem, we cannot survive, resist. And ecosystems are shrinking in the biosphere, and major factor which determine restitution of ecosystem services for society is water. That's why understanding interplay water ecosystem is absolutely fundamental to persist and to create the sustainable future. Hydrological cycle. First, we are homogenizing the agricultural landscape, and landscape without the land-water ecotones, landscape without land-water ecotones, landscape without the next slide, please. Yes, without land-water ecotones, without tree rows, losing the water. All the processes like soil erosion, loss of organic matter, heat budget, and soil moistures are dramatically modified and negative way modified. Also, groundwater recharge in such homogenized agricultural landscape is lost. So we have to try to restore the complexity of agricultural landscape to really restore to great extent the hydrological cycle. Second element is already river. River provides, next slide please, provides the sustainable water resources and has a big regenerative potential. It means after pollution, if we stop pollution, they can easily regenerate. And on this picture, we can see how much we are accelerating river outflow to the sea. And in this moment, if we create homogenized landscape, a urbanized landscape, we're losing water by evaporation and straightening the river, we're sending water to the sea. In face of climate change, getting warmer, in this moment, situation get dramatic, and all this process has to somehow reverse. And of course, next slide, the understanding water interplay needs money. But recent situation is that we have a very serious gap between the amounts of money which is provided for SDG, Sustainable Development Goals, and really which we spend. This is probably 3 times less. So then another challenge is creating low-cost advanced solution. And ecohydrology is by integrating the different scientists, highlighting life-supporting processes, is providing opportunity to create such solution. Next slide, please. But very important, we need new paradigm, but we cannot solve the problem the same way of thinking as we create them. Next slide, please. And New York conference, as I mentioned on the beginning, was providing 3 very important conclusions. Next slide. We have to reduce fragmentation of decision maker, but also fragmentation of knowledge. Ecohydrology putting together hydrology, ecology, and other disciplines, related disciplines, is reducing fragmentation of knowledge and in further step, fragmentation of decisions. Second, ecohydrological neighbor solution, which we already talked. This is a key role in enhancing biodiversity, not only preserving. Ecohydrology is more ambitious. We want to enhance. And finally, society, necessity to involve society. We have to do engineering harmony between society and man. Next slide, please. Of course, this already was introduced, and here ecohydrology in this document, strategic document already is, and WBSR holistic approach for us to ecohydrology is highlighted. Next slide. And climate and ecosystem. This figure is showing how important are terrestrial ecosystem in recycling, retaining, and filtering the waters. Red area is indicating that 80% of hydrological cycle is dependent on the ecosystems. And next slide. And however, we have to keep in mind that climate will be changing not equally in all the globe. We have some area where we more rain, more flood problems, this blue area, and red will be more dry and a bigger water deficit. So that's why all broad scope of adaptation measures is necessary to be prepared. Next slide. This model was really initiating the ecohydrology very long time ago, and however demonstrate that putting ecology and hydrology, reducing to the physics, we can achieve much better predictive potential of processes. We can easily define hierarchy of drivers in this ecosystem, and understanding hierarchy of drivers is fundamental for creating strategy and policy which is cost efficient. Next slide. Next slide, please. And of course, that's hydrology, ecohydrology demonstrate that we can regulate process to achieve enhancement. We can regulate biota by hydrology and vice versa, hydrology by biota. And we also can, next, we have to harmonize with hydrological, hydrotechnical infrastructure, create hybrid system, because we cannot replace hydroengineering, we just only can make more efficient. And third one, we have to integrate different measures. This integration need a really profound understanding of processes with water ecosystem interplay from molecular up to the catchment to global scale. Next slide. And now ecohydrology low-cost advanced solution. This is example when we put together on the beginning of ecohydrological experiments knowledge on groundwater level and willow biomass, bioenergy plantation. You can see that on the 20 centimeters, very high wetland groundwater level is very high. The maximum yield was 2 tons and minimum lakes was 400 kilograms. And when we put the willow on area when groundwater is much lower, we achieve up to 8 tons. So it shows that if we have a botanist who can advise to select best variety, we can double the crop. However, if we and also discuss with hydrologists who can inform us about groundwater level, we can increase 20 times economic efficiency between minimum, next slide, 400 kilograms, this dark blue, 0.2, up to the 8 tons. So this is showing the advantage of hydrology. Putting together the knowledge two disciplines, we can dramatically reduce the cost and fantastic way increase efficiency of measures. The next step, next example. And coming to the bigger scale, this is a very important example. Cities are now containing almost 60% of human population, there will be more. That's why creating blue-green compact city, which is not, let's say, added to urban sprawl process, is a very important way reducing impact of ecosystem. That's why putting the retaining the water in the city landscape is reducing and again green area, reducing the heat island and reducing the negative effects on human health and reducing the pressure on urban sprawl. Next one. This is showing also that the concrete city is increasing dramatically alpha benzopyrene concentration, the dark blue, showing that the impermeable space is very negative in increasing the toxic substances in there. However, green area, if you compare the asthma allergy among children, is very efficiently reducing 3 times of health effect. So we have to create, that's why blue-green city of the future to keep the health. Now the few slides, please go very fast. We come to conclusion because time is already go. This is next. Yes, and we can maximize the chance by purifying urban stormwater, and just because purification by ecohydrological biotechnologies, advanced nature-based solution like as above sequential bifurcation system allow to create such reservoirs or lower point of picture. Next picture, please. This was this idea in Parliament magazine. And of course, we can create, and here is example with Professor Jurczak, we create program in ECHREC when we already put hydro engineering solution with nature, ecohydrological solution, geochemical barriers, biomanipulation, plant buffering zone, which will be introduced more precisely on next lectures. And as you see, reduction from 165 milligram per liter suspended matter to 3.5, 20 times reduction by creating the hybrids. And all of this will be not only discussing in details during your visit in Łódź in September, but also we'll make some, let's say, measuring exercises, and also with some make joint construction of some variants of this solution. Next one, please. And creating this blue-green cities, allowing to avoid urban sprawl, which urban sprawl is reducing the city human capital and degrading environment surrounding, degrading agricultural land, as you see, forest degradation around the city, which are important for recreation, but also in some very dense area, pollution of fossil fuel, when fossil fuel are used for heating, are even bigger in the center of the city, so it doesn't make sense to really create such, let's say, process. Next slide. And of course, we now, next one, we change the paradigm from bottom up, next very fast please, from creating infrastructure, next up to the human health, life, human quality, and creating the friendly landscape, which is less costly than this concrete solution on the bottom, and which are not having any function like groundwater recharge, doesn't support biodiversity, and so on. Next one. And finally, WBSR. So we have to really improve our efforts towards sustainable development goals. We have to integrate water, not only water, but bioproductivity, biodiversity. This allows us to create ecosystem services. Having those one, we can create systemic solution for enhancement resilience. And also, of course, we have to implement such ambitious goals. We have to create culture and education of water and sustainability, which will be translated to law, policy, and governments. Next one. Next. And of course, to really conclusions, why ecohydrology is accelerating the DG provides new paradigm, evolutionary ecosystemic, by highlighting life-supporting processes, provide the background to create advanced nature-based solution, and all of this provide opportunity to enhancement, sustainability, water, bioproductivity, biodiversity, services for society, resilience to the climate change. And all of this will be in detail discussed during your stay in Łódź in half a year. Thank you very much.